Welcome to the CCNA course presented by Smart and Tech. Lesson 4 Networking Fundamentals Part 3. As you know, we will continue with our free CCNA 200-301 training course, which started by Cisco in February 2020. Lesson 4 Part 3. Let's discuss another subject, the types of computer networks. As you know, the network that we are discussing called LAN, Local Area Network, in which its coverage area can be one office or one building or even one campus, by using one or many switches of different sizes as required in the network design. LAN usually related to some local geographical area. This type of network is very useful. But what will happen if some company has different offices in many different areas? Like, they may have office in New York and other branch in San Francisco. There are other types of networks like MAN, Metropolitan Area Network, which is a larger network that usually spans over several buildings in the same city or town. The other type is WAN, Wide Area Network, which is a network that exists over a large scale geographical area. A WAN connects different smaller networks, including Local Area Network LANs and Metropolitan Area MANs. This ensures that the computer and users in one location can communicate to each other and communicate with other computers and users in other locations or other cities. The Internet is an example of one. Another point we need to discuss today: how the ISPs work. If we look at the New York office and San Francisco office, we can see that both of them are connected to the local ISP in his city. Maybe the same service provider, like Verizon, or different providers, like NY may be connected to Sprint, while San Francisco office connected to Verizon. The idea will be the same, even if the ISPs are different. The ISP company take a license from the government to establish service provider in the state or many states or full country, and then they start investing building a backbone in certain geographical areas as per their license. The ISP companies start to lay cables covering all the city areas with their related networking equipments, routers, switches, and other types of networking devices. They may have many offices even inside single city, and then they connect their network with the internet to start selling their services. So, when the clients want to connect to the internet, they have to subscribe on a monthly basis with the ISP to get their service. The ISP company then will lay the cables reaching to the client's premises and even fix the cables sockets inside their offices or houses. Install a router that connects the client with the ISP, Internet Service Provider. This small router has a modem inside it with a connection interface depends on the connection used. Like, if the ISP is using FTTH, fiber to home technology, they will lay an optical fiber up to your home or office, and the router will have optical fiber modem and GPON optical fiber connection interface. GPON means Gigabit Passive Optical Network. So, this router will have optical fiber interface from one side. From the other side, it may have an RJ45 interface, normal LAN interface. Modem means modulation-demodulation device, which is converting the transmitted data from one shape to another. For this router is connected to the Ethernet LAN from inside and to optical fiber GPON. So, the modem needs to convert the electrical signals coming from the Cat6 LAN cables to an optical signals, light or laser, going through the optical fiber, and vice versa. So, in the same way, we can consider the Internet tremendous number of WANs interconnected to each other, covering the whole world, providing lot of shared services. So, the Internet is a global computer network providing variety of information and communication facilities, consists of interconnected networks using standardized communication protocols. To put it in simple, Internet is a huge number of WANs connected together, here, 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 and here. So, if you have one person sitting in Dubai trying to access a website in USA, his request may go through one of these paths. One important application used extremely to access the Internet by everyone is the web browser, which enables us to go through the different websites around the world, google.com, youtube.com, and so many other websites. There are many web browsers and you can use any one of them, Google Chrome, Internet Explorer, and so many other browsers. So, how do we access any website? From the user point of view, it's very simple. Run the web browser, write the required URL, and then press enter. After a while, you will get the website that you requested. But technically, to do this, there are a lot of processes running in the background to bring the requested web page to you. In simple, if you want to view youtube.com, your web browser will initiate an HTTP request. HTTP is the protocol used to request any website. Then, the Internet routers keep forwarding your request until it reaches to YouTube server. After that, YouTube server will send you the default HTML file. When you receive it, you may click on specific video link, which means you are again requesting something from YouTube server. Then, YouTube server will send you the HTML page related to this link or this video which you requested, and it will be included in this page. YouTube will keep streaming this video until it completed or you disconnect the connection. So, this is how the Internet works usually. Another concept over the Internet we will discuss today is the throughput or data transmission speed. What is throughput? Throughput is measured in bit per second. So, What do we mean by bit? The bit is the smallest digital unit that computer can deal with. Consists of two states, either 0 or 1. The other unit used in computer world is the byte. The byte consists of 8 bits, and it's the smallest digital unit that can represent an alphabet character. So, in computer world, the size of a file that may have lot of characters measured by bytes, kilobytes, megabytes, gigabytes, terabytes, and so on. B will be always in uppercase, while bit will be in lowercase. Transmission speed measured in bits per second, which means how many bits this line can transfer from one location to the other in 1 second, and measured in kbps or mbps, gbps, gigabit per second, megabit per second, or kilobit per second, always in lowercase. Kilobyte is equal to 1024 bytes. Kilobit 1024 bits. So, to clear the relationship between file size and the transmission speed, let's take an example. Assume we have a file with 10 megabyte size. How long do you think it will take to transfer it from one PC to other over a link of 1 megabit per second speed? 10 megabytes multiplied by 8 bits divided by 1 megabit per second will equal to 80 seconds. So, this is how to calculate the time required to transmit any file at a specific data transmission speed for any file need to be transmitted over the internet or any network. Now, is that all what we need to know about the transmission speed? The answer is no. There are other factors which may affect the internet transmission speed. These are the availability and delay, which is always correlated to each other. For instance, PC1 and PC2 in New York office connected to switch 1, and switch 1 connected to the Ethernet interface of R1. Both connections have a speed of 1 gigabit per second, but the other interface of R1 is connected to the Internet Service Provider link with optical fiber and speed of 20 megabit per second. So, when PC1 communicates with PC2, the transmission speed will be 1 gigabit per second, while when PC1 requests any connection outside New York office, then the speed will be decreased to 20 megabit per second, because R1 will not be able to process the data coming from PC1 only at 20 megabit per second speed, because the other interface, which is coming from the ISP, is limited to 20 megabit per second speed. The internet speed also might reduce more if the ISP links at any place connected with a slower speed than 20 megabit per second. Like if the link between New York ISP router and Ohio router was only 10 megabit per second. So, the speed will be degraded again to 10 megabit per second only. So, in computer network, the transmission speed of a link considered based on the slowest node in the whole link, even if the other nodes have higher speed. In general, Usually, main ISP backbones have huge capacities and transmission speed than the last mile connection or client connection. The other factor that may affect the speed is the delay. For instance, if you are transmitting file from New York office to Dubai office, data may pass through many routers in between. New York to London, then to Madrid, then to Rome, Cairo, and finally to Dubai. While if you transmit a file from New York to Ohio, the data may pass through much less number of routers. So, the same file will reach to Ohio faster than reaching to Dubai. And for this reason, big companies like Google install content delivery servers at many places in the world to reduce the delivery time required to get your required service. So, if you are living in Singapore, for example, and try to access youtube.com, you may receive the video from YouTube server from Malaysia, not from USA, to deliver the video to you faster. Delay may happen also due to other reasons. While your data pass through many different routers in the internet, it may pass through one router that has a 1 gigabit per second speed of the backbone connection with the next node, which is very good speed. However, the problem is that this router has a very high traffic at this time passing through it, and the router is not able to process all this traffic in a proper way. So, in this case, your data might face delay, although the connection speed is very fast. The last factor affecting the transmission speed is the availability. If the link between Cairo and Rome were down or disconnected for any reason, and the user in Dubai requested a service from New York, he will not get the service due to this disconnection, or may get it but from much longer path from other direction. Dubai, Mumbai, then Delhi, Beijing, Tokyo, San Francisco, Ohio, and finally New York. This is a very long path. So, these are the factors which affect the speed of internet. Last subject we will discuss today is the network topology. What does it mean? Network topology, in simple words, means how the computers are connected to each other in a network. There are many types of network topologies used: star, ring, bus, mesh, and hybrid. In the star topology, all the devices and computers connected to single node, centralized switch. In this case, if the link of PC1 disconnected, then only PC1 will be affected, while the other PCs in the network will continue working normally over the network. In ring topology, if the link between PC1 and PC2 disconnected, then both PCs will keep also communicated with each other, but from the other direction. While in the bus topology, if the bus disconnected from the middle, then the three PCs on the left side will keep communicating with each other and still have access to the internet also, while the two PCs on the right side will communicate with each other only and will not have any internet connection. In mesh topology, all the PCs connected to all other PCs. This solution will provide very high availability and redundancy. Even if many links disconnected, all the nodes will be able to communicate with each other. But this is a very costly solution. So the main drawback in this solution is the cost, which will be extremely high. So this option might be used at the carrier backbone level for telecom operators, but not at the level of small networks. The last topology type is the hybrid, that can make a mix of two or more types of network topologies together. If we go to the network shown here, we will see that the PCs, servers, and even wireless devices connected in star topology, here, and here, while the switches connected between each other in a bus topology way. So if the link here disconnected between the two switches, then these PCs will be isolated from the network. Sometimes the switches have other redundant connection between them, so even if one of them disconnected, they can still communicate with each other through the other link. In this case, these switches connected in ring topology. So, as a result, this network as a whole considered to be connected in hybrid topology, combined of star, bus, and ring topologies. We will stop here for today to give you a chance to review the information given today. And please don't forget to subscribe to our channel or click on like if you find the information given today were useful. Goodbye and take care, future CCNA engineers.